Okay, so you guys can write some things down in your notebook. In a few minutes, when we get to a couple problems where we're going to need to do some graphics and fill out tables and stuff, I have a handout for you that you can do those problems on. But if you just want to use your notebook for your definitions and stuff, that's fine. So chapter 2 is made up of 5 sections, and then, bless you, at the end of chapter 2, we will do our first test in September, and then we'll do our first project as well over some of this stuff. All right, so this section is about frequency distributions. They're graphs, so we're going to look at like histograms specifically, and then a couple other graphs we can use that you might not have seen before for frequency distributions. So what is a frequency distribution? It's a table of values. You guys may have done these before. Teachers might have called them a tally table, if not or a frequency table instead of a frequency distribution. A frequency distribution is a grouping of data into mutually exclusive. Mutually exclusive is a fancy math term. It means they have nothing in common. The groups don't have anything in common, no values in common. Categories showing the number of observations in each class. When we say class, those are the groups. Okay, so our first group, our first class is 11 to 15. And then once we end at 15, the next class begins where the previous one left off. So 16 to 20, 21 to 25, 26 to 30, et cetera, et cetera. And we're going to make one of these in a minute, so you'll have a handout there. You don't need to worry about like copying this chart down. Some terms that we're going to use within our frequency distribution. First, we're going to use class width. Class width is how many data values are included in each class, how wide each class is. A common mistake when people calculate the class width is they take the first and the last values in a class and subtract them. Instead, what we do to calculate a class width is we take where one class begins and where the next class begins, and we find the difference in the two. Subtracting the 16 and 11 tells me I've really got 5 data values, and you can count on your finger for that first one, 11, 12, 13, 14, 15. There's 5 data values in each of those classes. Okay, so we subtract either the first value in each, or you can use the last value in each. That's fine. The bottom number is called the lower class limit. The top number is called the upper class limit. How we calculate how wide our classes need to be is we find the range of values, which you guys have done that before. That's our highest value minus our lowest value. And then you divide it by how many classes you want. So let's say my range is 50 and I want 5 classes. 50 divided by 5 tells me that each of them need to be 10 units wide. That would be my class width. When we calculate that, if you get a decimal, you always round up. So if I got like 10.3 when I did that calculation, I would round up to 11. That ensures that my classes are wide enough for all my data values to fit. If we round down, you're going to be stuck with all of your data values not getting in your table at the very end. Okay, so we're going to practice this with our typing test that we did yesterday, and we'll come back to these definitions in a minute as we get to them. So, took a picture of your results from yesterday. The first thing I need you guys to do is copy these data values down. 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay. 1, 2. Okay, so we are going to use your typing test data to construct a frequency table that has 6 classes. So go ahead and take a second and get all these values written down. Okay. All right. Let's start by finding my range, which is going to give me my class width. So in order to do that, you need to know the minimum value in your data set and the maximum value in your data set. What is the minimum value of our data set? Lowest value, smallest value. What do we got? Feel free to speak. Yeah. I think there's one lower than that. I saw 38. Okay. And maximum? 97. I think that's a 4. That might be a handwriting thing there. Is that a 4 or a 9? Is that 4? I think it's 4. I didn't write it. I'm thinking it's 4, but I don't know. What's the next highest one? 58? Yeah? Okay. All right. So your range, 58 minus 38. Range of our data is 20. Okay. To find our class width, we're going to take our range. We're going to divide by the desired number of classes, which in the instructions here, it's telling us we want 6 classes. So 20 divided by 6 gives me 3.3 repeating. So my class width that I'm going to use is 4. Perfect. Okay. So now we're going to go to the table at the bottom of your paper, and we're going to start filling things in. We are going to start with the number 38 because that's our minimum value. All right. So 38. And we want our class width to be 4. So remember, that isn't the beginning and the end of a class. So I'm not going to do 38 and 42 end to end. It's going to be 38 and then 42 right below it. Okay? We're going to fill in the ends of them later. Keep adding 4. 46, 50, 54, 58. Where does the first class have to end if the next one begins at 42? What do you think? 41. Perfect. And you can count on your fingers again if you want to make sure there's 4 values within that range. 38, 39, 40, 41. There's 4 in there. Okay, and then you can just keep adding 4 to that to get the end, the upper class limits. 45, 49, 53, 57, 61. Okay, so lower, had to label it, are these guys. Upper are those guys. Any questions so far? Setting up our frequency table. This is typically the hardest part, just making sure all the numbers are where they're supposed to be. Hold that thought. All right, F. I'm going to go back to my definitions here. F stands for frequency of a class. That's listed down here if you see that, okay? So that is our tallies, essentially. How many data values fall within that range of numbers? We're going to, once we have our frequency, our F values, we're going to calculate a midpoint, a relative frequency, and a class frequency, or cumulative frequency, and then also our class boundaries in a minute, which I have a definition for. You'll see all of those at the top of your table there. Okay, so F is our counts frequency. Midpoint is exactly what it sounds like. It is the middle of each class. So we're going to take our lower class limit, our upper class limit, and divide by 2. It's just the average. N is divided by 2. Relative frequency is kind of like our percentages, okay? What percent of our data is within each class? To calculate that, we have a fancy formula for it. It's our class frequency, F. so how many data values fell in that class, divided by n. N represents our total sample size. How many of you did the typing test in this case is n. Okay. Cumulative frequency is the frequency of the class that you have plus the frequencies of all the classes prior to it. Okay. The sum of the frequencies of that class and all of the previous classes. So in our table in a second, we're going to do an example of each of these so you'll see what those look like. All right. The other definition we need to know is class boundaries. Class boundaries are our class width, our upper and lower limits, extended by half a unit in either direction. So if you're looking at this example here, if I have a class of 18 to 25, my class boundaries are 17 and a half a unit down, to 25 and a half a unit up. Class boundaries do overlap. Where one ends, the next one begins. So this ensures that we don't have any gaps when we're looking at our frequency table. It's also helpful when we get to graphs like a histogram. If you remember doing those before, the bars have to touch. So we need a place that our classes have in common. Okay, so back to our table. Let's fill in all of these things. All right, so F, you can tally if you want first. I would recommend just putting a single number in this column. It is the frequency of the data values that fall in that class. So for the first F value, we're just going to count up how many data values are anywhere from 38 to 41. So, and you can cross them out as you go. I would probably recommend that so we don't miss anybody. 38, what else do we have here? Are there any other ones? Is that it? Nope, just one. Okay, so my frequency of that class is 1. The next one is 42 to 45. Let's see, 1, 2, 3, 4. I've got 4 of them. Okay, 46 to 49. 1, 2, 3, 4, 5. 50 to 53. 1, 2, 3. 54 to 57. 1, 2, 3. And then 58 to 61, there's just one data value in that class. At the very bottom of that column, the total of all of your frequencies should equal your n. So the sum of that column is our n. So if I add all those up, and you can count the data values at the very beginning, even if you want to, just make sure everybody's accounted for. 5, 10, it looks like we've got 17 at the bottom. Okay, and that's a sum. You're going to see in this class a lot, we're going to use the summation symbol. It kind of looks like a capital E that's sort of diagonal. Have you seen that before? Probably, hopefully. Maybe don't use it a lot. But. Okay, midpoints. May or may not need a calculator for this, depending on what your numbers are. Midpoints, we're going to add up our ends and divide by 2. So 38 plus 41 gives me, what does that give me? 79 divided by 2. So 39.5. Does that sound good? 39.5. Okay, 42 plus 45, that gives me 87 divided by 2. That sounds like 43.5. You will notice, if you're doing this correctly, the midpoints should increase by whatever your class width is. You can see those first pair there, they increased by 4 when I went from one to the next. So at this point, you really don't need to keep doing the calculations. You can just keep adding 4 once you've done it a couple times. Make sure you're right. All right, so 47.5, 51.5, 55.5, 59.5. Okay. Class boundaries. Take your class upper and lower limits and extend them by half a unit in either direction. So 37.5 to 41.5 for the first one. 41.5 to 45.5. 45.5. Hi, Ryan. Thank you. That was supposed to be a 4 there. Okay, good there? Any questions so far? All right, relative frequency. Remember, this is like our percent, the percent of the data that falls in each of these classes. The formula that you need for this is your value of F for each class divided by N, total number of data values. And if you need to round, we're going to stick with round to 3 decimal places. It's going to be appropriate for pretty much the whole semester. All right, so 1 divided by 17 from my first class gives me 0.059. 4 divided by 17, 0.235. 5 divided by 17, 0.294. 3 over 17, 0.176, and that's going to repeat again in that next row, 0.176. And then 1 out of 17, we did that at the top, 0.059. Now, if these represent the percentages that fall in each category, what should the sum of this column equal? 100. Equal 100% or 1. So that's a good way to check that your relative frequencies are correct. It should equal 100% at the end or 1. Okay, finally, a cumulative frequency. Cumulative frequency is the frequency of the class you have plus all the ones before it. So in the first class, it's just that first frequency 1. In the second class, we take 1 and we add the next group to it, 4, and we get 5. This number will get larger and larger as you go down the column. Then I'm going to add 5 on, 10. Then I add 3, I get 13, 16, 17. If you're doing this right, that last value, your final cumulative frequency, should be the cumulative frequencies of all the data in our set, or N. All right. Questions here? Wonderful. Okay, so what can we do with a frequency distribution once it's created? We can make a bunch of graphs. Most common one that you're going to make is a histogram. You have probably made these before. So a histogram, we're going to have our groups at the bottom, and we're going to have, it's going to look like a bar graph, but our bars are going to touch. There are 2 ways that you can label your horizontal axis. We want to ensure that the bars touch. So first option is you can label with class midpoints. If this picture was labeled with class midpoints, I would not have numbers on either end of the bar. I would have one number in the middle of each bar. That would be my midpoint. Or you can label with class boundaries. So this one is labeled with class boundaries of whatever this data is. We don't have the data, but these are the boundaries where one group starts and the next stops and the next group starts. Your vertical axis is just going to be your frequencies, so how many trees are in each of these ranges. It could also be, instead of frequencies, a relative frequency. So it might not be counts on the side here. It might be percentages on the side there instead, and we use the relative frequency column instead of the frequency column from our distribution. Okay, so if you flip your paper over that you have on the back, we're going to make one of these. Actually, we're going to make two of these so you can see the difference between a frequency histogram and a relative frequency histogram. The first one, it says we're going to use class boundaries with the results from our typing test. So class boundaries, and I'm going to have to flip back and forth, so forgive me a little bit here. It started with 37.5. So we always want to start at 0. If you can't start at 0, we're going to put a little break in our graph, a little kind of squiggly at the beginning. And then we're starting at 37.5. And then we're just going to count up through the class boundaries that we have. They also increase by 4 if you look back at all of those. So we should have 6 groups that we're creating. Make sure you space them out as equally as possible. When we draw it by hand, it's not perfect. We know that, but we want to do the best we can. 41.5, 45.5, 49.5, 53.5, 57.5, 2, 3, 4, 5. I need one more if I can squeeze it in there. 61.5. Okay. Label, label, label. Okay, so this represents your data, words per minute is what our data came from. Okay. This is just a frequency histogram. So on the side, we label frequency. And these are our counts. They're going to go from 0 all the way up to our end value of 17. You can count by whatever you want here. I'm just going to count by like every 5 maybe. 10, 15, oops. Actually, you know what? I take that back. What's the highest frequency that we had? We don't need to go all the way up to 17 for this one. It was just 5. So let's just count up to 5. I can count all the way to 17 if I want to, but all of my bars are going to be really low, so we might as well kind of zoom in on the data that we want there. Okay, so our first class had a frequency of 1. So our bar goes up to 1, and then you can color it in. Okay. Second class had a frequency of, what was it? 4, and then 5 for the next one. Okay, so make sure you're touching that other bar. Obviously, if we had a straight edge, that would be ideal here. We're just doing our best right now. I'm going to show you in a couple weeks, we're going to do a day where we just work in Google Sheets. And I'm going to show you how, if you enter your data correctly, it will create these types of graphs for you, which is ideal, obviously, because we can, you know, have nice, pretty straight lines, and it's generated for us, which is awesome. All right, up to 5 for the next group. The next 2 groups were at 3. And the final group was at 1. A relative frequency histogram is what we're going to create next. When you guys make these, when you do like projects and stuff, you'll have a choice whether you're using class boundaries or class midpoints. It won't tell you. I just wanted to do one of each though. So that was class boundaries. We're going to use class midpoints next. Okay. So again, we're going to have a break in this graph. Our first class midpoint was it 39.5? Does that sound right? Yes? Okay, so that's going to be in the middle of one of our bars. 39.5, then we're just going to increase by 4, 43.5, 47.5, 51.5, 55.5, 59.5. Okay, and again, label the bottom with whatever our data stands for. It was words per minute on our typing test. On the side, this time it's not frequency, it is relative frequency, which are our decimals, our percentages. So we're going to start at 1 or at 0, and you could go all the way up to 1, but we don't need to in our case. What's the highest we need to get to? About 0.3. Okay, so we'll just label 0.1, 0.2, 0.3. All right, my first class had a relative frequency of 0.059. So when I draw this histogram bar, it's going to go halfway, about halfway, up to the 0.1. And it's going to be on either side of that midpoint that I've labeled 39.5. Okay. And then just make sure your bars touch and continue that process. 0.235 and 0.294 are my next two. 35. 0.294. 0.176. And then the last one was the same as the first one. Okay. Do we see any similarities here? Graphs look pretty much the same, right? So the relative frequency shows us the same sort of distribution and clustering of our data as a frequency histogram, just another way to label it. Okay, so make sure when you're reading your instructions, you know which of the two you're doing, because really the biggest difference is going to be that vertical axis there. Boundaries or midpoints might be told to you in Math Excel, but again, you'll have the choice when you guys do that yourself. All right, and we're going to stop there for today. The bottom two graphs on your paper we're going to do on Monday. The last two types, the polygon and the OGIV, I think are the two we didn't do yet. And then we'll do a little exit ticket with our graphs, and then you guys will have some time on Monday to work on your Math Excel. Okay, 2-1 Math Excel is due on, oh, it's on our new calendar. When is it due? 2-1 Math Excel. The 30th, so that is Tuesday night next week. All right, so you can start it this weekend if you want, or if you would like a no homework weekend, I'm okay with that. Whatever makes you happy. All right, so we got about, I don't know, 17 minutes now. If you want to do a little, you can. That's fine. Rachel, have you drawn yet? Yes. Have you drawn yet? Who hasn't drawn yet? Don't look. We're trying to cheat. 15. 15. Oh, somebody won. What's the number 15? Victoria. All right. Those quizzes will probably be graded today. So you can check back on Polaris, see how you did. There you go, ma'am.